good morning and welcome everyone. For those of you that has just landed into this session, this is the session 3, and the name of the session is Making Science as Open as Possible and as close as necessary, of course. But we will talk about the open science, making in a general term. I remind you that this is the third parallel session into this final conference named Inspiring Researchers on the Use of Open Science in their Research Project. That is the final conference of the project Greco, which I've been involved for these 3 years, in charge of the coordination of one work package related with open science and responsible research and innovation. Greco is a multinational research project funded by the European Commission, and its main goal is putting open science into action in a real research project in the photovoltaic sector. But as you have seen by the program, there are in each session there are many panelists, many speakers from a multidisciplinary background. Even in our session, there are 3 speakers from the life and health sciences and 1 from photovoltaic sector. That it's the reality of research, because we have in common that we are using these tools related with open science, and it's a common practice for all of us, independently of the sector that we are working on. But I just to stress this, because I just to recommend to the panelists, to the speakers, that when they talk, they take in mind that they are talking for people that are coming from other sectors, and maybe some technicals or some technical words or specificities should be to be explained a little bit more. It's just a recommendation that of course I'm sure you will do it. So we have more or less 1 hour to this session. 4 panelists. Each panelist has around 10 minutes. I will send a message by chat when 1 minute before 1 minute of the 10 minutes, because if I see there is missing a lot, and then of course at the end we have almost 20 minutes more or less for the debate about what is being explained here, but also for general debate about open science. And I have also the questions that you write in your registration. So I hope it could be a nice debate. So let's start. The first speaker is Kathleen Hare. She's doing her PhD in the Center for Clinical Brain Sciences at the University of Edinburgh. And she's going to talk about translational failure in preclinical research, how open science can help. So Kathleen, the floor is yours.
Thank you. I'll just try and share my screen. So yes, I'm going to talk about translational failure in preclinical research and how open science can hopefully help with this issue. So first of all, what is translational failure? And I wanted to use this diagram to kind of illustrate what the problem is. This was from a systematic review, which looked at interventions to treat stroke in both animal and cell models. So they identified over 1,000 interventions that have been tested in these models. Over 600 have been tested in animal models of stroke. Just over 350 were effective in these animal models. 97 were taken forward into human clinical trials, and only 1 was actually effective in the human clinical trials. And this loss is not just within the stroke research field. This is across the board in biomedical research. We see this in the drug discovery for Alzheimer's disease and various other diseases, that we see in the animal models that the treatment seemed to have a positive effect, but then when we bring them into the clinical trial, it fails. So why does this happen? So either the clinical trials are incorrect and they're not finding the results that they should, or the animal studies are incorrect and they're over-promising that a result will be positive. And we know that within the life sciences, there are perverse incentives to produce positive and exciting results, that we found a new drug treatment for Alzheimer's or stroke. And these positive results are more likely to be published in high impact journals. They're more likely to achieve future funding, and the researchers are more likely to achieve promotion. So there is this perverse incentive to get these positive results out there. There's also a pressure to reduce the number of animals used within individual experiments due to for ethical reasons, but also in terms of the timescale of the project, and the amount of funding dedicated to the project often doesn't allow large numbers of animals to be used. But what this means is that the studies are often underpowered, so they don't actually have enough sample size to detect the effect that they're looking to find, so they can't actually answer the research question very well. And these factors work together to compromise the utility of animal models and contribute to the translational failure that we see. So this is another example from the pharmaceutical industry, where they tried to replicate academic research findings of laboratory research. So they were trying to replicate studies that had claimed to find a new drug target that worked across different diseases, such as cancer biology and cardiovascular disease as well. And they were unable to replicate 65% of those academic findings. And interestingly, it didn't matter whether the findings were published, across multiple papers had found this new drug and claimed that it worked. That didn't seem to matter. It didn't lead to increased reproducibility. So this hopefully kind of illustrates the issue that we have with reproducibility as well, and verifying our results. And I just wanted to touch on some of the things they also mention in this paper about trying to improve the validity of experimental findings in animal models. So there's something called internal validity, which reports to the strength of the cause and effect relationship within a study. So how much, if you give an animal an intervention or a drug treatment, how sure can you be that it's your treatment that's led to the improvement in outcome versus some other random factor that's impacting on your results? So to minimize the risk of that happening, you should randomize your animals to experimental groups and be blinded when you are assessing the outcome, so that you don't know which is the treatment group and which is the control group. There's also external validity, which is how generalizable your results are across different laboratories, how generalizable they are from the animal to the human condition, and how generalizable across different species and different experimental setups. And these types of validity are actually really hard to determine, because quite often the researchers don't report in enough detail for us to actually assess the validity of these scientific claims, which can lead to overestimations of how well a treatment actually works. Because we've shown in our research, doing large-scale systematic reviews of the literature, that failure to report these things can lead to overestimations of treatment effect. And finally, I just wanted to touch on reporting bias as well. As I mentioned, positive findings that a new treatment works are more likely to be published, and they're more likely to be published in high impact journals as well. So again, it leads to kind of the studies which might find a negative finding or no result might just still be in the file drawer and might not even be published. So it leads to this overestimation of how well treatments work. Also, in the papers themselves, sometimes researchers might omit certain outcomes that they measured. So if they looked at animals performing across a range of behavioural tests, they might only report the outcomes of ones that kind of agreed with their hypothesis, and maybe omit the other outcomes. And sometimes journals ask authors to remove outcome measures as well. So together, this means that the reproducibility, replicability, and reliability of biomedical research is under threat. And if this is the case, then it stalls our scientific progress. It means that we have this translational failure, time and money are wasted, and it can lead to a loss of trust in scientific findings. And it can also lead to talented researchers leaving the field because they become disillusioned with these perverse incentives. So I just wanted to quickly highlight a couple of open science kind of tools that we can use within the preclinical research community to try and improve this problem and reverse it. So firstly, I wanted to just mention study protocol registries. In the clinical space and doing clinical trials, they're always pre-registered, or they should be. And what I mean by that is the researchers will set out in advance what they plan to do, how they plan to do the study, how they plan to analyze the study, and what analyses they intend to do, and what outcomes they intend to measure. And there are now dedicated preclinical registers so that you can do this for your animal research as well. And this allows us to help us to confirm that studies report what they set out to do and minimize some of these reporting biases. I also wanted to mention registered reports, which you might have heard of. These are a new kind of publishing format where you submit essentially a pre-registration to a nominated journal, and they can put it through peer review so that you can actually change your study design based on the peer review at that stage before you collect and analyze your data. And then you can receive an in-principle acceptance from that journal. And then no matter what your results are, whether you don't find anything exciting, they'll still publish your paper because they've approved the methodology. So this again will help minimize the reporting biases that we see, but it will also help us to incentivize transparency and getting all of the research findings out there and disseminated. There's also open methods, so things like electronic lab notebooks, which I know we're going to hear more on later. There's also protocols.io, which is a website where you can upload your protocol in a lot of detail. You can refer back to it in your publications, and it can be especially useful if, for example, the journal has a limit on the methods section and you can't write in enough detail. There's also the RRIDs, or Resource Identification Initiative, which essentially is a database which assigns ID numbers to things like antibodies and different reagents and models used within the study. And all of this works together to ensure we have clarity on how studies were performed, and will hopefully assist with us being able to determine how valid a study might be, assessing things like internal validity and external validity, and also assisting with replication efforts as well, because the researchers trying to replicate should be able to see in enough detail to do that. Also, ideally, data should be shared, and there's a number of ways to do that across lots of different repositories. But there's also journals now like Scientific Data and BMJ Open Science, which accept data descriptor articles where you can go into a lot of information on your data set and share it as a publication, which is good for you, publication wise, and people can cite that when they use your data. But of course, there's no point just putting your data online undocumented. It needs to be documented in a way that people can actually use it. And ideally, if you put your code online as well in your analysis, people can actually check that, which can be daunting, but science is incremental, and we don't want to be, doing future studies based on results which are incorrect. So it does benefit us all in the long term. So finally, I've just highlighted a few tools. There's so many tools that exist, and we're going to learn more about them today as well. Research is still ongoing to determine the efficacy of these different tools and how exactly they can improve the robustness and reproducibility of preclinical research. More education is required on the benefits for researchers, and ultimately I think that there's benefits to science in general, but I think, as others have said, rewards and incentives are the things which are likely to drive real change in this area. So thank you very much. I'm happy to answer any questions you have.
Okay, so thank you, Caitlin. Thank you. Congratulations for your very clear presentation and very well explained. You are a very good communicator. Even if it's an experience from the life science sector, I'm sure that it's important, and it should be. It is very helpful for all other sectors in research. We will let the questions at the end of the 4 panelists. and because maybe some of questions are common for all of you. So thank you very much. Then we go to the second speaker. She's Dr. Celine Hein. She works at the Unit Animal Welfare and Knowledge Transfer at the German Federal Institute for Risk Assessment. And she's going to talk about pre-registration, how to bring transparency into animal research. So the floor is yours, Celine.
Thank you. Thank you also for the invitation. I think it's a very nice format to exchange experience in open science between all these different research areas. And I was very happy to hear also the first talk from Caitlin Hare, which already gave a nice introduction also to the problems we are facing in animal research at the moment, and which allows me also perhaps to cut a little bit my introduction and keep in time. So with our pre-registration platform, which was also mentioned already in the first talk, the animalstudyregistry.org, we try to address these problems. But before I come to this this platform, I would just show you a little bit one other motivation we had to launch this pre-registration platform. It's just something very basic, but which is often forgotten, is that basic fundamental and preclinical research is still relying on animal research, and it's still a very controversial topic in society. And even already children really instinctively refuse the concept of animal testing. However, to gain new knowledge and to permit scientific and medical progress, we allow on a strict legal framework animal experiments, because we are hoping that this will perhaps bring a medical breakthrough or new insights. But now comes the problem. There are more and more new studies which show that actually a huge part of animal experiments which are performed are never published. And so all the knowledge gained from these experiments are actually lost if they are not shared. And just to show a little bit what we're facing, what we're dealing with and what are the numbers, I would like to show two little studies. I will not go into detail, but which try to find an estimate, an objective estimate on the percentage of animal experiments which are actually lost. So these both use a similar approach, and the European Union to perform an animal experiments, you need to apply to write an animal study protocol to where you describe all the experiments planned, and only then you get a permission and can start working. And what they did now, they looked at these animal study protocols and made a follow-up from these protocols and looked 6 years later, what was the percentage of animal protocols which led to at least one publication. And what they found is that there was overall only a publication rate of 67%. And if they excluded doctoral theses, as the sharing is not as broad, this number even dropped to 58%. And there was also a study from the Netherlands where they found a similar number with a similar approach from just 60%. And when they looked at individual animal numbers, so the animals which were planned for an experiment and what was found, what was reported in the publications later, this number even dropped to, I cannot see, 23%, I think. So it's very low. I think we cannot really put a perfect number on it, but in general, we can see that there is a big amount and a big loss of data and a waste of animal lives. And this is where we would like to which motivated us to build this pre-registration platform, which you can find on the animalstudyregistry.org. And it's a similar approach to clinical research, where for most clinical trials, it's already mandatory to fill out to pre-register the trial. And we thought this would be a good idea to do the same for animal research. And you can just go to the page and also just browse through already pre-registered studies to get an impression. You don't need to create an account. And what you can do on this platform is once researchers, scientists, which plan an animal study, once they develop their idea, they can fill out the form for their study plan, where we ask questions about study design, statistics, methods, and housing conditions of the animals. And then later the study plan is submitted. And after submission, they still have 2 weeks where they can edit anything or retract the whole study. Otherwise, it will be automatically registered, meaning it receives a DOI, so a digital object identifier, and cannot be changed anymore. But this doesn't mean that it's immediately publicly accessible, because we know that there's a fear of the scientists to get scooped or that the idea would be stolen. So we and counter this by giving them the option to choose an embargo period for up to 5 years, where the study is only visible with the title, the institution where it's performed, and a short summary, and optionally the name of the author. And only after this period, the whole study will completely be publicly accessible. But we also know that, of course, from the plan to the conduction of the study, a lot of things can happen. And to allow to add any changes or comment on any changes, we give the option to add comments anytime to the study, where these can be explained and where also others can learn from the experiences. And in the end, this comment function will also help you to link all the outcomes, the data, or even the publications to the study plan, and then permit really the comparison between what was planned and what was published in the end. And we believe that this pre-registration will encourage then the publication of all gained results, which will solve this ethical issue, which I was talking in the beginning, but also diminish the size of the publication bias, which was really nicely mentioned in the first talk, often leads to an overestimation of effects of tested interventions. And it will also promote early planning of the study and really already prevent problems or mistakes which are done in the beginning when planning the study, so no blinding or the randomization, and this will also help in the reporting later, because all important points are already covered. And it will also prevent all the I would say current but bad practices like p-hacking, so meaning that you play around with the statistics until a significance is reached, or hypothesizing after results are known, which can also impact the validity of your results. And it will also promote transparency, because you can really follow the course of a study. So yeah, perhaps a little bit about our experiences with the registry. So in general, we get a very positive feedbacks if we interact with the scientists, but we have to admit the uptake is still very slow. So since 2019, we're online and we have now 80 pre-registrations. I have to say that in the last months, we really see that there's an increase. So we believe that slowly it starts also we're getting more known, and people are more interested in pre-registering. And we get pre-registrations from all over the world, which is really nice and very surprising. Yeah, from all countries. And yeah, it would also be interesting for us, of course, to know from where they know us, and yeah, why they're interested. And so what we do now to really try to increase this progress and increase the uptake of pre-registration is what was already mentioned so often today, is that, of course, with the incentives at the moment are really having the most impact on how research is done. And so we try to really talk to stakeholders to create incentives for pre-registration. So we already talked to institutions, and there are some institutions which give money for pre-registration, or publishers which recommend it now in their guidelines, or funders which ask that it's a prerequisite for the projects which are funded. And with this, I would like to end. And perhaps one thing which I didn't mention is that I am working at a federal institute, so we are not dependent on any sponsoring, and we can really guarantee also continuity. And we are also focusing on data protection. And yeah, I would be I'm looking forward to the discussion. Thank you.
So thank you very much, Celine. Also a nice presentation and very complementary with the one from the previous speaker. I can remember very well when many people claim for a database on clinical trials, something 30 years ago. So I'm really happy to see that there are a lot of work done in the field, also in animal research, that and to avoid losing data and to accelerate research. So both of these examples are very, very nice, and hopefully we will have a nice discussion at the end. Thank you very much. So the third speaker is Professor Antonio Martí. He is full professor at the Solar Energy Institute at the Universidad Politécnica in Madrid. As you know, the Solar Institute is the leader of the Greco Project, and Antonio has been in one of the central points of this project. He's going to talk about reflections on the use of notebooks, why or why not using them. So Antonio, I give you the floor. The floor is yours.
Thank you, Regina. Well, first I would like to say what is an open notebook and what we understand by an open notebook. It is, I would say, it is a notebook, but a notebook that you want to share with others in electronic form. I will describe two types of notebooks. One of them is the notebook you use for implementing code, and another one is your research notebook. That in this framework it receives a specific name, which is in the literature, which is electronic laboratory notebook. So I go first with the code notebook type. I'm going to give you some reasons why to use them. Well, probably the first reason is that it allows others to verify your results. I will illustrate this with an example. Well, as you know, we work in the field of photovoltaics. So at some point you could do some modeling and claim that you have invented a solar cell that has an efficiency of 120%. Of course, with the result, people become skeptical and ask you for the model you have used to predict that result. So you give them your model, probably in the paper where you have published it, and your model is correct, but still the result is not trustable. So then what you need is to share with others the program, the code you have used in your calculations. And for that, you could give the others the proprietary your code, even if it is done in proprietary software, for example, LabVIEW or Mathematica or something like that. But in a more rigorous context, probably perhaps if some detailed calculation is involved, probably people might not trust the compiler you are using, or how your software is using the decimal digits. So if you want to go one step forward in this respect, you need your code to be implemented also in open software. So the other reason is that when you develop software, especially if it is very complex, you need others to collaborate in it, well inside your team or even outside your team. In this case, also emerges the necessity of using non-proprietary software, because especially if you want a collaboration worldwide, some institutions won't have licenses for MATLAB, for example. or even if you want the students from other parts of the world to collaborate, they can afford the licenses or things like that. So in this respect, it's also better, I think, to work with non-proprietary software. Also, especially, well, this is really depending on the project you are involved, I guess. But for example, if your software is for working with a medical instrument or for controlling a nuclear plant, probably it's also a safety concern that others do, to allow others to verify your code in order to increase the security or the safety in the context where this software is going to be used. But another reason is that perhaps here I'm talking more specifically of a notebook for documenting your software, is that with today's tools, you can make your code appear as text. For example, this is one example of code we actually use. So probably it looks like a notebook, but if you go in detail, when it comes to the part of the modeling, you can check the equations and how the calculations are actually implemented. Another reason for using it is that the tools you would need, they actually exist. For example, you have GitHub for hosting and version tracking of your codes, and for example, tools like Jupyter for actually implementing the code. Well, in our deliverable 4.7 in Greco, you can find an extensive discussion of what I have just presented. Well, these were the reasons for using it. What about the reasons for not using it? Well, one reason could be that you lose competitive advantage because, well, you perhaps have spent 2 years developing your code and you are going to document it very well. So in a month, almost, I would say, anybody can use it. Well, you have lost your competitive advantage because now everybody can use that tool for modeling the research. Another reason is that you are exposed to others to see how bad you are at programming. Well, especially if your code is going to be exposed worldwide. Well, I think this is better because it's a way of improving, but it is true that you are ashamed, and I say this for because it's a personal experience, you are a bit ashamed of sharing your code when it's still not nice. But also, when you aim to sharing your code, you realize that in addition to the tools you need for developing your code, you need to find your way about how to upload the things in the cloud. You need some knowledge of how the internet works, and also, well, if you are working at the university, or you have to be careful where you put eventually you put your software, because you could open a door at university for malicious software to enter. And this complicates the things. And the conclusion is that when you want to do all of this, it's time consuming, because once you put, for example, the things in GitHub, well, the less thing you have, I mean, at least you have to attend the questions people post at your webpage or at GitHub. You have to review the changes others do. And you also, if you are new to this, or you have to teach your mates, or you have to train students. And for example, if students come every 3 years, you have to repeat the teaching every 3 years. Well, if you are in university, you can accept that this is part of your duty. but you have to also to be aware of that this is going to delay your research because you need more time for this. And sometimes you were using a proprietary software, as I said before, but when you want to share it, you want to make it non-proprietary, what means you have to translate it. And this is difficult because sometimes the tools you have in the proprietary version, you don't have them in the non-proprietary version. And even if you have them, then you have to go to a complicated process of testing everything again in order to see if it works properly. And also there is the money issue, because if you have, I mean, you need institutional support for hosting the software, or if you are going to host it elsewhere, you need money for paying the hosting places. You need projects to pay them. But this is difficult also because sometimes when you start a project, you start a software, there is a project to pay, but when the project finishes, then you ask another project to pay what you developed in the first project. So the second project says, this is not my business, I'm not going to pay for something you developed elsewhere. So everything becomes very complicated in terms of paperwork. So at the end, very often you decide that what you're going to do is to create your own account, because often it only costs you like 5 euros per month. And you prefer to pay by your own rather than to go into very complicated things of justifying how you are spending the money. Also, then there is what I call the Windows Mac nightmare, because you develop the software, you want to collaborate with others, and they say, this doesn't work because I am in Windows, this doesn't work because I am in Mac, this is not compatible, I cannot use that, I cannot use whatever. So it is not easy to find a common tool for doing everything. So from my personal experience, I would say that these kind of open notebooks are not worth for small projects. You need an IT expert with you if you want to do it properly. And it would be ideal if you get the students already trained in these tools rather than training them by yourselves. So about the other tools, about the electronic laboratory notebooks, well, why to use them? First, because you can collaborate with your colleagues in the same experiment. This is a screenshot of one of the software I will recommend later. You see that you can divide your work in teams and members of the team. But then you learn that there are other advantages that perhaps you were not aware of. For example, nothing is deleted. So even if you accidentally delete something, or even if you delete it on purpose, and then later you realize you need it, you need again the result, you can go back in the versioning system, and what you deleted is there. So there is no way of deleting anything once you have typed it in. Also, there are things like timestamps. For example, if you suddenly you discover something, you believe it is important, you can claim that you have discovered that. And then later, through some standards like RFC 3161, you can claim later for intellectual property of what you have discovered at that time. About why not to use them? Well, it's difficult first to find a commercial tool that fits your needs. So in this respect, if you are interested, I would recommend you to go to this web page of the University of Cambridge, where you can find different electronic notebooks analyzed in terms of suitability, platform, storage, cost. Well, when you go through the options, for me, for example, you often find that they are not open. So when they are not open, you don't know what they can do with the things you upload there. Also, it is not clear in some cases how to recover your data. For example, if you decide to pay for one of these tools and later you want to move to another tool, what happens with the data you are storing in the first tool you chose? You have to pay for recovering the data. How do you translate from one notebook to the other? Also, some of them are very expensive. We enter again into the problems of how to finance these tools. But after all this analysis, I would say that I would recommend, I have found one electronic laboratory notebook that I find very, very suitable, which is eLabFTW, that I strongly recommend because it has these timestamps, it's compatible, you own the data, it's open source, it has all the advantages I mentioned before. So I would say I recommend to use it, even if it is for your own use. Even if you don't want to, don't have the possibility of sharing it, or you don't convince others for sharing your electronic laboratory notebook, it's a notebook that you can access, for example, from your phone at any moment. So definitely it's very good, and I recommend it. Okay, thank you very much. This is all.
Okay, so thanks a lot, Antonio. This is, I think you are the only one that are using open software for your presentation also.
Yeah.
Thank you. And then I'm sure at the end we can comment how was the experience of using open notebook at the Solar Institute, how much is extended the practice right now, before and after Greco or something like this. But I think it's very interesting that you have shared your experience with pros and cons of the using open notebooks. So we are going to the fourth speaker right now. She's Madeleine Pownall from the School of Psychology at the University of Leeds. Madeleine is going to talk about engaging with open science as feminist early career researchers, 6 top tips. So Madeleine, the floor is yours.
Thank you very much. Let me just share my screen.
Good.
Can you see my slides okay?
Yes.
Okay, excellent. So I'm going to be taking a slightly different kind of presentation. I think it actually follows on really, really well from the last talk. So I'm going to be talking, it's actually 5 top tips because I thought that was a bit neater than 6. So there's 5 top tips. So I am a PhD student in social psychology. So everything that I'm going to be talking about has a bit of a kind of psychology edge to it. But I'm hoping that it will give us some stuff to discuss. So I see this talk as being a kind of Kickstarter for our debate and discussion. So hello. So what I'm going to be talking about, and I'm going to probably try and keep this quite brief because I think I'd quite like to get your thoughts on it and discuss things a little bit. So this quick presentation follows on from a paper that I led on called Navigating Open Science as Early Career Feminist Researchers. And this, which is the reason why I was invited to speak to you. So this paper was written by a collective of 10 feminist identifying early career researchers, who the vast majority of us were from psychology, but we had people from neuroscience and life sciences in all different places. And it's available as a preprint, and the link there is if you're interested. Hopefully it'll be out soon as an actual paper, but we'll see. And these are some of the questions that we kind of sought to discuss and think about. So, and they're the kind of questions I think I'd be very interested to chat to you about. So we were thinking about things like how do we, as people who are early in our career, for people who are, some of us are PhD students, some of us were lecturers, some were postdocs, how do we kind of navigate this world of open science? So some of the people who wrote this paper with me were very established kind of open science people. They were doing their PhD thesis about open methods, and kind of knew all about open science. And some of us, a bit like me, were kind of new to this conversation. And the open science conversation is particularly always been happening quite a lot in my field of social psychology. We were also interested in how the goals of open science and feminist psychology can inform one another. And we can speak a bit more about this, if you like, a bit later. So we were interested in things like the idea that feminist psychology and open science, kind of in terms of their epistemology, so in terms of how they approach science and how they approach knowledge, that feminist psychology and open science both champion things like collaboration and transparency and acknowledging bias and working together, and trying to improve accessibility. So we were grappling with that a bit. We were also interested in what can open science offer us, so in a very practical sense for early career researchers at the start of their career, what are the kind of practical benefits? And also more broadly, what do we need to be wary of? So are there things within this kind of open science conversation that are potential barriers or things that we need to kind of think about before we go into open science? So it took I think it took just over a year to write this paper, because we had a lot of thoughts and a lot of ideas, and there was an awful lot of kind of nuance in this that we grappled with quite heavily. And we ended up, the first thing that we did was we started by thinking about what are the kind of core issues for being an early career researcher. And we're talking about psychology, but this applies to anything. If you're an early career researcher, if you're a PhD student, what are the issues, what are the kind of things that we need to think about when we're trying to encourage early career researchers to engage in open science? So a couple of these are here. So we were interested in things like the need for top-down institutional support. So how can you engage in open science without that support? We were also grappling with issues such as the ways in which labour is distributed, how early career researchers can take appropriate credit for their work. How do you grapple with wanting to do slow, good, reproducible science, also with this kind of pressure to produce that we feel as early career researchers, so the need to have papers in order to get a job. Time pressures, vulnerability, compatibility with qualitative methods, and there's been some ongoing conversations about how more qualitative methods can be kind of negotiated in open science spaces, and also more practical things like the need for training. So these were kind of our core list of issues, if you like, that we then kind of took to discussing. And off the back of all of these, we came up with a list that I'm going to share with you, that were our kind of 5 top tips for if you're an early career researcher or if you're someone who supports early career research, what are the things that might be particularly useful? So I appreciate that not everyone here is an early career researcher, but I think it's kind of useful to think about how best we can kind of support like the new generation of researchers in this context. So these were broadly our kind of 5 top tips. And I'll go through them like semi-quickly, because then we can talk about them a bit more. So these 5 tips kind of come from a much broader discussion around all of the issues that I talked about. So around issues of transparency and vulnerability and the need for support and all of these kind of things. So just to go through them. So one of the things that we, from kind of our experience, because I really like that this conference is all about kind of researchers' own experience, we kind of acknowledge the need for early career researchers to like start at their own pace. And I think that there's often this perception that open science needs to be kind of all or nothing. So you need to make everything open or you don't do it, which kind of ties into our 4th point about this idea, which ties in very nicely to the title of this session, about being as open as you possibly can, and about acknowledging that open data is a wonderful thing, but not all data can be, for very valid ethical, legal, epistemological reasons, and not all data maybe should be open, which we can talk about a bit more in terms of ethics and consent and all of those kind of things. We also talk quite a bit in our preprint about the need for community as early career researchers. So things like this lovely conference, spaces online, such as online communities on Twitter, these kind of pockets of open science conversations where we can start to grapple with how can I do it and what does that look like for me? We were also talking about the need to engage in what we call, or I like to call, research advocacy, which I think feels quite important in the context of some of the discussions that we've had today. So this idea of trying to dismantle what's sometimes referred to as the hidden curriculum in higher education or in open science. So for example, I think we often talk quite a lot about the potential tools that are available to scientists and the value of those tools. So things like pre-registration or doing a registered report or making your data open, which I think we can all kind of agree have wonderful benefits. But I think it's also really useful to think about how, who is kind of governing that process. So how do people who are early in their career, who may not have access to institutional support or supervisor support, or just have the kind of know-how or ability to seek out that support, how do they then engage in it? So kind of this sort of educational capital, if you like, which I think is quite a nice way of putting it. So one of our tips, which I think is a tip for early career researchers and also just for researchers, is this idea of not pulling up the ladder behind you. So if you manage to suss something out, which is similar to what we were talking about in the last talk around, if you know how to do open software, thinking about how you can kind of advocate for people who might not have access to that, the hidden curriculum of open science. So the first kind of 4 tips that we talk about are very focused on the kind of practical, how you can engage with it, how you can make your data open, how you can kind of be part of this open science conversation. And I also think it's useful to consider our 5th tip, which for me is kind of the most important one, which is what we call do what you need to survive. And I think that this is something that felt really important to me because I think open science is wonderful and making data open, and I think if there's infrastructure, it's excellent. But we also know that there are an awful lot of competing pressures in early career academia and academia generally. And we know about things like neoliberalism and the pressures to produce and pressures to compete. And I think it's important that in spaces like here, we kind of critically consider how do we make sure that open science isn't just one of those kind of other things that early career researchers also have to be kind of actively evidencing, if you see what I mean. So I said I was going to be quite brief, so I've just got one other slide because then I am actually really interested in having more of like a discussion about this, if that's okay. But I think as well as the top tips, we also speak a little bit about what would an open science that is kind of responsive to all of these concerns, what would that look like? So this is our very kind of blue skies thinking vision of what open science could look like. So the kinds of things that I'd really like to kind of open up a dialogue about are things like, how can we challenge some of these quite entrenched power dynamics? So this whole thing around people who have access to know how to do this stuff and people who don't. How can we really meaningfully acknowledge the fact that not everyone may be able to participate in some of these tools and some of these activities as other people? What does good, meaningful, kind of engaged, top-down institutional cultural support look like for people early in their career? Like what are the needs and how do we meet them? And I was actually at a talk earlier this week from Professor Stephen Curry, who talks about the need for institutional buy-in, and he was proposing several ways of doing that, which I think were really interesting. And also, how do we kind of foster a version of open science that is really genuinely responsive to kind of more critical, creative ways of doing things in a way that doesn't respond to that with hostility? And there's this wonderful paper that I'll link to if I can find it, by Kirsty Whitaker and Olivia Guest. And I really like this quote from there, and they said, there is no open science if science is not open to all. And I think, yeah, I'd be really interested in chatting about how can we make science open to all in light of some of these kind of barriers that we're talking about from an early career perspective. So that's my talk. These are all the people who wrote the paper with me, who are all excellent and wonderful, and I'm speaking on behalf of all of us. But yeah, I'm very interested to hear your views and to have a discussion.
Yep. So thank you very much, Madeleine. This is nice to see your presentation, and thank you for your tips. I'm sure we can go to many of them during the debate. We have just 10 minutes for this discussion. Let me remind you that you have the chat if you want to write your question or your suggestions by the chat, but you can also use your camera, because we are in a small group of 22 or 23 people. I think it's better if you use your camera, just raise your hand. Okay, we can start if you want with your last tip that is related with the pressure that open science could provoke in the early researcher's career, and it is somehow surprising me, this commentary, because no, it's not surprising because I thought before in it, but it is in somehow a paradox with this, and a commentary here in the chat from Ivo, that Ivo told us it's nice to see that open science could be good for the next generation when following their tenure track, because open records could be included into the criteria to evaluate the careers. So this paradox between the open science is good for the careers, but also could provoke a pressure for early researchers. Maybe you, Madeleine, or some other in the panel could give a short comment.
Yeah, I do see often some things around embedding explicitly open science into things like promotion criteria and job applications, which I think is wonderful and definitely one solution. I think that is kind of one of the major kind of infrastructure answers, because then all of the tensions that we're talking about around getting credit for this and the kind of invisible labor that's often associated with open science, that's a really nice kind of concrete way of responding to that. And I think more broadly as well, that our point around like do what you need to survive, which is probably a bit dramatic, but I think one of the inherent tensions I feel is this, there's been some really interesting conversations in the kind of open science community around the need for like slow science, and to like slow things right down, do things more thoughtfully, embed pre-registration, and kind of trying to rebut this idea of like fast, efficient, sloppy science. And I think that there is I completely agree. I think science should be slow, and I think that I'm very receptive for things like team science approaches and community science approaches. I think what is perhaps lacking from some of that conversation is around what that means for early career researchers who are, in light of all of this stuff, or despite all the stuff around wanting to slow down science, are still expected to have outputs after their however many year PhD. And I'm not quite sure what the solution is. All the solutions are, but I do think that that's probably one of like the biggest tensions that we were concerned about. I'm more than happy to slow down my science and to publish less and do kind of bigger pieces of work rather than lots, but then what does that mean if I then don't publish anything and I'm trying to compete for a job?
Thank you. René, have you raised your hand?
Yes, I did. Thanks for all the good presentations. Actually, it's actually amazing to see that we all seem to share a sort of same diagnosis on the problem in the scientific world as it is right now. I'm just delighted to see that, because I've been suffering in the commission for 15 years with an uphill struggle to get open science on the agenda. You know, and RRI as well. I mean, so now it becomes more and more, you know, a common thing to push for. And just to, I actually should have mentioned this in my talk, but this also responds to the problem. I think in the funding system, we actually now in Horizon Europe, I think this is, I mean, I'm not here to advertise all things of the Commission as such, but this I think is really a good thing. This is namely that open science will be evaluated under the excellence criterion. So that means that if people would now apply for funding in Horizon Europe, then they have to, they can list open science practices. And if they do so, and if they are appropriate for the research project, then they will get better evaluated, so to speak. So it's an extension of the you know, former excellence criterion, which was too narrow in my view. And this will incentivize, of course, open science practices. So this will also include, for example, if you would engage with other knowledge actors in society to conduct your projects with. And so that there is then now a strong incentive to do that. I think there are no equivalent there are no other funders at the moment in the world who have extended their excellence criterion in that sense, to my knowledge. But I think this is one of the solutions in terms of funding. It's not sufficient, of course. The real issue is, of course, that the universities have to change their habits. I mean, this is, and in some universities have done so, but a very few only. And there is actually an interesting discrepancy between people who have all signed to all kinds of declarations, be it the San Francisco Declaration and changing the method and so on, but they don't do it. They sign even declarations, but the universities don't follow it up in practical matters. So we live in, it's actually a very schizophrenic situation. It's so schizophrenic that like if you talk intellectually, you know, everybody knows that these metrics are rubbish. So let's just put it like this: there's crap actually, and everybody applies it. I mean, but nobody wants to defend it publicly. It's all because they know it's crap. But this happens. So this is a very strange situation. I think one has to put it like this. It's the solution is in the universities' hands. They hide themselves behind a strange form of autonomy, which is not defendable in terms of public funding of research and innovation.
Thank you, René, for this reflection. I agree that the universities themselves are in a competitive competition to show the excellence, and at the moment the excellence in science is shown as it is. So Ivo, please, could you have you raise your hand? You can add some, or you can explain better what you have said in the chat.
Maybe just a short comment. I commend Madeline and co-authors on publishing on this. It's really the right timing. So I train a lot of Marie Curie ITNs and individuals. There is definitely this frustration on, oh my God, there's so much to do. When am I going to do my research, right? If I really want to be open science progressive. So I really appreciate this message on do what works for you. You know, take baby steps. You don't need to go for all of it. It really is the right way to strike balance between committing to this idea without going completely crazy and still stay somehow putting yourself on an employment position. However, there is something else maybe for the young researchers. René mentioned now open science is becoming a stick, right? It's a mandate. You want to win, you got to do it. And in the last 5 years, it was more of a carrot. It was a soft a benefit. It wasn't so explicitly tied up to funding. However, in that 5 years, we ran an experiment as part of the Open Science Clinic where we thought, right, let's see if we could push youngsters to go above and beyond what templates require them to do, right? And those that let us really hack their grant proposals and include as much open science as they are comfortable. Sometimes we're pushing their comfort limit. They won. They got positive comments at evaluation. It made their proposals more competitive in a moment when open science was not requested. So I guess the lesson there is, yes, go at the baby steps that you're comfortable with. Don't go crazy, but also keep in mind that templates are there just to show you the direction. But if you have the courage to go above and beyond what templates ask you to do, you're definitely in a winning position and you definitely get more benefit.
Thank you very much, Ivo. I think your words are very helpful for all of us. We have just 1 minute, and I wanted to ask to Antonio just to share with us the experience with your team when you entered in Greco project with the juniors and seniors, just the feelings that your team has working in this open science experience. And now that we are finishing the project, do you think they will continue to expand their open science practices or not? Just a brief comment.
Well, it is a very interesting question. For example, I also wanted to do an experiment in the sense that I didn't want to force anyone to use, for example, the electronic laboratory notebook I mentioned, because I think that if you want to go into open science, it has to be because you find the tools useful, not because nobody forced you. So, for example, in the case of I can give you some figures. In the case of the electronic laboratory notebook example I gave, we learn about it during the project and is here to stay. But the reason, and it goes in the line of these small steps you mentioned, is here to stay because at least I'm going to use it. But for example, when we gave a talk about how to use it, and I would say that 20 people started using it. And now I would say that only 3 of us are using it. And the 2 other persons that are using it are the technical ones, because they find very useful to find in this notebook all the information and to write in the same place all the information. But the laboratory notebook, the general idea is to share it internationally. And in this respect, we haven't done it because for the moment it's only useful, I think, for us. I mean, I don't think it's interesting for the world how often we run the maintenance of a machine or that. Although eventually I realized that if an experiment comes from a machine, eventually people might be interested in whether we have maintained it properly, because in the sense that the machine has not degraded, so the result of the experiment is okay and things like that. But as I think I mentioned and other people mentioned, I would say that people like open science, but when they face the tools, we face the problem of the learning process, of the problem of going down with our research, and we live in a competitive environment. And to be honest, if I need to train a PhD student in 3 years, and after these 3 years he or she is going to need a job, I'm not sure I can afford or recommend him or her, okay, go publish 2 papers in open journals with no impact, while your mate in the next room is going to publish 1 paper in a high impact journal. I mean, I'm not sure I can recommend that.
Thanks, Antonio. Thank you very much. Of course, it's not easy. There are still a lot of problems and issues that we have to solve, and they will have. We can still talk in a lot of hours, but we can. Yes.
If allow me, just one quick thing. Please don't forget that open science is not free as in beer. If you want to develop it, it also needs money. So
Hi, sorry for interrupt, but we should start finishing this.
Okay, no, we will finish right now. Okay.
Okay.
Thanks, Mario. So sorry for the rest of people that couldn't talk. We have just very few time. And thank you very much for all of you speakers and participants. I think it was a very interesting table with a learning message for all of us, for our professional, personal lives. And thanks a lot and congratulations for all of you. Thank you.